Why would you say that?
Class.
Yes, yes.
It's all right. So 1-4 is a continuation of what we were doing in 1-3, so it's probably something that you appreciate doing. It's not too challenging. That's coming. Don't worry. All right. So go to this slide right here. Slope-intercept equations. In the last section, 1-3, we graphed them and we evaluated them. We talked about points on the line. In this section right here, we are writing the equation of the line given the information, okay? So this should kind of ring a bell. They're telling us to write the equation of a line that has a slope of -7/9 and a y-intercept of 0.16. We have multiple options here. You could do point-slope formula, or you could do slope-intercept form. For right now, let's do slope-intercept form so you can see how would you do it using that equation. So I'm going to keep in mind y equals mx plus b is the slope-intercept form for the equation of any given line. If I wanted to write the actual equation, I need m and b. I need to find the slope. I need to find the y-intercept. Well, the beauty of this problem is they give me the slope is -7/9, and then they tell me that the y-intercept is of the form 0.16. So they're telling you that b is what number? 16. So we can go straight to our equation here. You're only plugging in the values for the slope and the y-intercept, but it's not enough to leave it like that. I want you to get it in what's called standard form, which means you have to clean it up. You need everything that is a term with a variable to the left side. The constant is on the right side by itself, and there's another aspect of standard form I'll show you in a second. So I'm going to add the 7/9 over here. It becomes positive, bring down the y, equals 16. The other aspect of standard form is there's no fractions. Standard form is nice integer values. So I clearly have a fraction here. I need to get rid of the fraction. To do that, I'd multiply by what? 9. Yeah, you should know this. It should be comfortable. We talked about in chapter R, if you ever need to get rid of a fraction, multiply by the denominator. You're going to do that on both sides. Now, the 7/9 would just become a 7x because the 9's would cancel. But you do have to, you may need to draw the arches. You do need to remember that 9 is also multiplying with the y. And then 16 times 9 is 144. Now, despite the fact that the numbers are bigger, do you see how much cleaner that equation looks compared to -7/9x plus 16? So I want you to box this in and make a note that this is standard form. And if you need to, underneath it, you can write the formula for standard form, which is ax plus by equals c. Now, what if I gave you the equation as a graph, and I said, or the function as a graph, and I said, write the equation of the line from the graph below? You still just need the slope and the y-intercept. So you would go on the graph and look at it to identify where is it crossing the y-axis. To get the slope, you're going to have to count rise over run, which means you need to start with your lowest nice point, rise level to the next nice point, and then run to it. So in this case, the only nice points I can see are the ones on the axes. I can't tell exactly what's happening like between here. So I'm going to count from this y-intercept using rise over run to get to the x-intercept. So I would rise 3, then I would run in what direction? 6. I'd run left 6, which means negative 6. So as a reduced fraction, it would be negative 1/2. Then you would write the equation. And then you would get it in standard form. So I would add 1/2 to the left side. Negative 3 would be on the right by itself. What would I multiply both sides by? By 2. Now, what do I need to write for the coefficient of x? What would I end up with?
1.
A 1, but do I want to write 1x? No. We don't want to have to write 1x. So the equation that you come up with originally, this one, that was the rubber end of it. That equation is the exact same as this equation. It's just one's in slope-intercept form and one's in standard form. But if you went to your graphing calculator and graphed both, they would overlap. They're the exact same line. I just need you to know both ways. This one's too easy. You just plug it in. I want you to be able to get here because on my math lab, on some of it, it's going to say write the equation in standard form. All right, go to the next one. You try it. Or you start it at least. It's a little different. What is the difference? They're not giving you what? The y-intercept. Instead, they're giving you what? A point on the line. Well, if you read through, then you take notes. Slope is what letter? Careful.
N.
There you go. All right, and then you've got a point. What variables does a point represent? X and Y. So they've given you M, X, and Y, which means we need what? We need B. We don't know it. And I'm going to copy here what M already is. So we've got to find B. Well, what was the formula for slope-intercept form? So this is just a matter of being analytical and saying to yourself, okay, well, I have a formula. I see an X, I see a Y, I see an M. There is a B. So I can plug in what I do know and solve for B. So plug Y in, plug X in, leave B alone. You've done this before. It was supposed to be taught in geometry at some point, and then they changed the geometry standards. So I don't know if that was, if you got it, or if y'all had the new geometry standards. But then it was also taught in Algebra 2. We are going to go deeper with it. This is just to remind you of what the groundwork was. So I'm going to clean this up. I've got negative 2/3 times negative 3. You could just multiply that straight across and then clean it up. Or you could recognize a negative times a negative is a positive, and then this 3, which is being divided, and this 3, which is being multiplied, are inverses. So I'm left with just what? 2. Subtract the 2. Now I know value of B. y-intercept
No, I just put that point on the graph and just, like, it's just a,
and counted?
yeah.
Yeah.
Just a right across.
Yes. You need to know how to do the algebra in case they're not integer values and you wouldn't be able to necessarily count it. Could be decimals, really ugly decimals. So make sure you also understand how to do it this way in case it's not convenient numbers that will map out nicely. I'm going to come back over here and put an empty box because we didn't know it and now we do know it. It's 4. So now I can write my equation. Y equals mx plus b. But I need to get it in standard form. I'm going to add this over. Multiply by what? Multiply by 3. And that is a much nicer equation than the original. Yeah, no, I'll go back and wait. You're good. You're good. Yeah. Which brings us to point slope, which is another equation of a line you can use. This is the actual equation here. The purpose of point slope is what if they give you a point on the line and a slope, the slope of the line. Instead of having to use slope-intercept form on the last slide that we did, you could use what's called the point slope equation. It's important for you to understand where the equation came from. They didn't just make it up. Direct your attention here. You don't have to box this in. I just want you to look right there. Okay. That's the equation of slope, right? Y2 minus y1 over x2 minus x1. All they did was group the x difference and cross multiplied over here, and that's how they got point slope form. So this is how they derived it. They just took the equation of the slope of a line, cross multiplied that over there, and that's where it comes from. You do need to know that if you are writing your final equation for point slope form, you only plug in values for the x1, y1, and then the slope. You leave the y and the x alone when you're writing the final answer. Because it's like over here. Notice I left y and x in there because I'm writing the equation of a line. I have to have a y and an x in there. So make sure when you plug your final answer in, you only put numbers in those 3 positions. The other 2 positions stay as the letters y and x. Okay, so let's try it. Here is the equation. I copied it to the next slide for you. Here's the example. It says find an equation of the line containing the points 2 and 1, negative 4. Or 2, 3, and 1, negative 4. So this is exactly what I was just telling you about, where they give you 2 points. So if you use point slope equation here, then you look at the points, and it might help to stack them so you have them lined up and you can see what you're working with. there's two ways to find the slope between those 2 points. You can use the good old-fashioned way that we talked about yesterday, stack them and subtract them, or you can go to the point slope formula. Since the goal is finding slope, you want to draw an arrow above that so that you'll remember that's the goal. If that's the goal, then everything else has to have a number plugged in, right? So pick a point, 2 and 3, and we're going to plug it in for x and y. Pick another point, 1 and -4, and we're going to plug it in for x1, y1. You don't want to mix those. You can't call this x and then this y1. You can't do that, okay? So whatever you call it has to be consistent. They're either xy and x1, y1, or x1, y1, and xy. As long as you're consistent and you don't mix them. And now we're going to plug those in carefully. So you got 3 minus y1 is -4, so you could put a plus sign here, or you could say, I'm just going to write it and then I'll deal with it in a second. Then you have 2 minus 1. So now clean that up. That's 7 equals 2 minus 1 is m. So I just found the slope to be 7. You didn't have to go that way. You could do the stack them and subtract them. But that also works too. And then you don't have to memorize the slope formula because it's right there. Okay, so the purpose of what we just did was we found the slope. Remember, to write the equation in slope-intercept form, we need slope and y-intercept. To write the equation in point-slope form, we need the slope and a single point. Well, now we have the slope, and we have the choice of 2 points. So you're going to pick a point. It does not matter which one you pick, they're both on the line. I'm going to pick smarter, not harder, which means if I've got smaller numbers or no negatives or any zeros, those are the ones I pick. Smaller numbers, pretty numbers, zeros, no negatives. Those are the ones I go towards. So I'm going to pick 2, 3. Doesn't matter though. You could pick 1, -4, plug it in, do it right. You'll still get the same answer. So where it says pick a point, I'm going to draw an arrow to say, okay, I picked 2, 3. This is now going to be your x1, y1. And then, of course, you already found the slope was 7. So plug it all in. We've got y minus, changing colors, y1 equals slope, parentheses x minus x1. Everywhere there is a purple variable is where I'm plugging numbers in. So y minus 3 equals 7 parentheses x minus 2. And now let's clean that up and get it to standard form. So distribute the 7. The good news is you've already found the answer when you're right here. But now you got to clean it up. I'm going to combine my constants. I'm going to add 3 to the right. And I'm actually going to do 2 steps in one because I'm running out of room. I'm going to add the 3 to the right, and then I'm going to move the 7x to the left. See how I did that? I did 2 steps in one because I'm running out of room. Added 3 to the right under its like term, subtracted 7x to the left, it becomes negative. And then the other caveat to standard form is your leading term should always be positive. This is technically not standard form. You need to multiply the whole thing by -1 so that your leading term is positive. So if you need to make a note to yourself, standard form, say no fractions, leading term is positive, and it's ax plus by equals c. Are there any questions on that problem? Anybody? Did you understand it?